Alright, hi. We left off here last time when we were looping around our hardware detection loop, which actually worked quite well. So let's isolate that a bit more, and now we want to support our display. So now that we can figure out what devices we have, we can do some work to compare stuff. So let's um, let's do this a bit more cleanly and have a display device ID B and a display device ID A. And this one, whoops, this one will be our first bit. So 0x7349, yeah, 7349. And this one will be F615. So F615. And what we want to do now is, after our hardware query, we could look up if this actually works out. So if B is display device ID B, I'm lazy, and if this is equal to that, then we will do hang on. Alright, we will use another subroutine. And this one will be display detected. And first of all, every time you write a subroutine, put this at the end, just to make sure that it always returns to where you want it to be. And now, whoops, now we want to jump subroutine, and our subroutine will be display detected. Now this will call that, and it will jump back at the end. And now what we do is, we know that I contains the ID of the device we want. So we will use, oh hang on, we need these brackets of course. That would have been embarrassing, wouldn't it? Okay. Anyway, we will set the display ID to the value ni. So now we know our display is there. And what I will do now is I will put a breakpoint there, and we will run this and see if we get there. Alright, and I is 2, and A and B have the correct values, so now we've found our display. And next we want to figure out what to do with it. But of course, we kind of don't know that right off the bat. So we need to look at the specifications here. And the first thing we will need to do is we need to map our memory screen. And that's really important. The way the display works is we have some memory region that stores the information that's drawn to screen, and this will have to be exclusively for our monitor. So let's say we use I don't know, let's say we use 0x for 00 and the next few bytes. And by few I mean whatever the resolution requires. So we can look that up. It's 32 times 12 16-bit cells. And that means we need 768 words. So it will take up the memory region from here up to, well, I should get this in base 16, I think. So I'm stupid, sorry. 768 decimal is 300 hex, so it will take up space up to there, our display. But we kind of need to make sure that we get that, so let's have another one, another constant, and this will be our display buffer. And what we want to do now is look at the specs. What interrupts do we have? Interrupts to hardware are just triggered with the hardware interrupt command, which sends an interrupt to the hardware that's specified here. So how does that work? Well, we set the A register to the name of the command. Well, not name, but the index of the command. So we have this, and we want to call it to the device display ID. And that's our handle basically for the display. But before that, we need to set the A and B registers accordingly. So A has to be 0 because our interrupts require that. If A is 0, then it's mem-map screen, and it reads the B register and maps the RAM to the address at B. Except when B is 0, then it's disconnected. So now we will set B to the value at the display buffer. And now if this runs through, which I really hope it does, then we stop there. Now we stopped here, and now let's step. A becomes 0, B becomes 0x4000, and now, hopefully, our display has been set to that memory region. But of course, there's nothing there yet. So just to check if it works, hang on. Alright, I closed the program. Now we've mapped our screen to the display buffer address, but we kind of need to try stuff out. So I'll do something really quick and dirty, which I will remove in the next video or prior to the next video. And I will write to the address at B. B becomes our display buffer. And I will write some value. Let's take that one. Well, just 45, that should be an E, I think. And let's see. I'll step through this step by step. So now, IS2, we find our display device. We map the screen. And we should have written this value here, which is an E, but we don't see it. So, what's wrong? Obviously something has gone wrong, right? Well, I think it's because we always reset the device again. It might just be that I've been really lucky and gotten black as a color. So the first few bytes here are the color, and those aren't bytes. The first byte is kind of color information, and the last one is the ASCII character. So let's try this again. And let's step through this. And now here's our E. So I had just picked a really bad color. And now we know our display buffer is working. We can actually write stuff to screen now. And that's what we will do in the next video. Thank you for watching. I know this one was really short, and see you.